All right, so first things first, what we want to do is take out the 4 bolts on the front plate here, and then we're going to undo the 4 bolts that are also part of this front guard, but then also the brackets for the left and right guards that cover the chain for the slicer here. And we're also going to undo these 2 bolts here, 2 bolts here, and then we're going to undo all the bolts that hold this big plate on, which will be the bolts that you have to hold down this plate on top of the gearboxes. So this plate has to come off as well. And once that plate, these guards, and these brackets and the front guard are off, we're then going to expose everything underneath for the slicer. And eventually we're going to go ahead and open the slicer so that it allows us access to the blades and the 2 anvils that are inside. It gives you a really easy access to do what you need, work in a really nice environment as well. So we have all of the guards off. We've got this front guard off. We've got the top plate removed from the 2 gearboxes, and the front of the plate mounts to this bracket right here. I have undone the master link, and it's the link where you can find this clip to undo the chain, which goes from each gearbox to each sprocket, their corresponding sprockets, on the slicer assembly here. So the other thing we have to do in order to pivot this slicer assembly up and out of the way are 2 things that we have left to do. We have to remove that bolt from each side of the slicer and loosen these 2 bolts on either side. This 1 bolt here, 1 bolt here, and that will allow, and then also these front bolts here, 1 on this side and 1 on the other side, and that then we can pivot this whole assembly up and out of the way so that we can get access to these anvil mounts, and then have easy access to go ahead and check the gap clearance between the blades and 2 anvils. The other thing you might want to do is remove the inlet feeder and the regurgitation chute. To do that, very simple. You just undo these 4 3/8 bolts. There are 2 on this side and then 2 on that side. 1 there and 1 there. And then that whole assembly just comes up and off of the machine. That will make it easier for you to, get your forklift over here and put a strap on that bracket, and then, start pivoting this whole assembly up and out of the way. And so that's what we're going to do next. During operation with the sidewall chipper, there will collect material behind the rear set of slicer discs on the machine. That is okay. The cover that has the air duct to it is magnetized, so it's very easy to remove these 2 covers and periodically clean this material out. We usually recommend, if you're running the machine 8 hours a day, you're going to need to clear all of that out a couple times a day to make sure that the dust collector that you're using still has good airflow through the slicer discs to keep the discs cool, and as well have the ability to still collect any small fragments of rubber or dust to keep it out of the air. And so so that you're going to need to check for that a few times a day. One other note here while we've got this open is the slicer discs need to have crisp edges on either side of the stack of 3 discs, because cutting occurs on these 2 edges that I'm pointing to right now. Now these discs are a special material, so they will last a very long time, but eventually you want to pay attention to these edges over time, and as they start to get rounded, you're going to see a decrease in cut quality in all the chips that come out of the machine. You're going to see more fraying of nylon, and if you have the ability, you would read a higher amperage as opposed to when the machine is brand new on these two motors right here, the two slicer motors. It's just because it's not cutting as well, so obviously you need more horsepower to perform the cut when it's not able to cut as efficiently. Again, that is months and months down the road. These slicer discs last a very long time. You know, it's proving to be at least 12 months of continuous solid work before our customers are having to replace these discs. And you can simply call us or email us to order a set of new discs. We do recommend it. It might be nice to have a second slicer unit on the shelf so that you can send a used one back to us to refurbish, and that way you're never down. Now, another thing to note here too is these threaded rods are connected to the tips of these dangling fingers. They go through the machine, and down at the bottom, these threaded rods connect to their tips. The threaded rods are there to hold those tips in place. And so while you're cleaning all this out, you just want to make sure that nothing looks loose. These nuts need to stay tight. The rods should look good. We want to make sure the rods haven't moved and are getting scraped up against any of these slicer discs here. That has happened before. That's okay. We can just replace the rod. It's a very simple thing to replace. No worries there. So those are some of the checks that you want to do when you've got these two back panels open. You've got a set of rods here to hold the rear fingers, and then you've also got a set of rods up front that hold the front fingers, the ends of the front fingers. Welcome. This is our Sidewall Chipper model SC15-1. And what we're going to talk about today is what's going on here between the two rotating blades and the two stationary anvils. And the machine we have in front of us now is still in assembly, so there are some missing gearboxes and motors. But in essence, you have the opportunity with your machine to pivot the entire slicer assembly, which is all these meshing discs here, up so that you can service the lower part of the machine. To raise this portion of the machine up, the slicer, you have to unbolt the two bolts that mount this bracket to the lower half of the machine. There's one on this side and one on this side. You undo those and you loosen up these bolts right here. You can then take a forklift with a strap and pivot the slicer assembly up and out of the way so that we can easily service this entire area of the machine. And there normally are sprockets right here and chains. You will have to unhook the chains to get this slicer assembly pivoted up as you see it now. Talking about safety, whenever this is open, absolutely you have to put some object to prevent this from coming crashing down on your hands and arms while you're working. It is an absolute must. You absolutely have to prevent this from falling back down. Using a forklift with a strap is another good secure way to make sure it's not going to fall down on anybody. And as always, make sure the machine is completely unplugged from electricity and air. All of its power sources completely unplugged. So now that we have access to this part of the machine, let's go ahead and talk about what's going on down here. Okay, with feeler gauges, we're going to check the gap that exists between each blade relative to each front cutting edge of each anvil. These are the anvil mounts. The specially hardened plate underneath is the actual anvil that can get flipped once and replaced. The blades, as you can see, have slots in them, so we can move the blade outward away from the center axis of the rotor assembly so that we can get the very tip cutting edge right on the front edge of each anvil. So with feeler gauges, what you want to do is start with a thinner feeler gauge and check the gap that exists between the cutting edge of the blade and the leading cutting edge of the stationary anvil. And right now on this particular machine, as you can see, I would have to force the blade very hard to squeeze this shim. So I am saying that this gap is less than 0.005 inches. That's a very, very tight tolerance. We check it over here, it slides past. And that's okay. You're gonna have a little bit of variance across the cutting edge of each blade relative to each anvil. We try and ship the machines out with as close to a 5/1000th of an inch tolerance as we can get. As you use your machine and this cutting edge wears down, this portion of the blade is going to see, which is the closest to where the operator stands, is going to see the most wear and tear. And that's because the regurgitation material is entering back into the machine in this half. So all these surfaces with this anvil, and each blade, this half towards the operator side is going to see more wear quicker than this side. And so you want to check this half of the machine more often than the other half. So if I take the next size up shim, a 0.006, and I try and pass the cutting edge, it hits. That's how I know I am truly between 5/1000ths and 6/1000ths of an inch. When resetting the blades relative to the anvils, the procedure is to loosen these 6 bolts that hold each blade to the rotor mount. So you can see we've got another blade here. You're going to loosen these 6 bolts just enough so that you can use the backing bolts to push the blade on its mount. You want these bolts to continue applying some pressure so that the blade is flat against the very accurately machined edge on its mount. If these bolts are too loose, you will get an inaccurate reading when you take your feeler gauges and take your gap measurement and then tighten these bolts down. It's going to suck the blade on farther and you're going to have a wider gap than what you thought you measured. So you want some torque on these so that it keeps the blade flat, but it's not too tight where you can't, you still have the ability to use these backing bolts to thread them and push the blade this direction relative to the cutting edge, which will bring it out towards the front edge of each anvil. Now, what's also very convenient about how we've designed this, these mounts here can be unbolted and worked on the bench. And that's very convenient if you need to unbolt. There are flathead bolts that hold these anvils onto this mount. And so sometimes that can be very convenient to do on the bench instead of being underneath the machine trying to feed an Allen head up through the bottom of the machine. The one note we will make is from the factory we have to use shims to space up the sides of these anvil mounts so that it's as accurately flat to the cutting edge on the blade as we can get them. So always leave these shims where you find them. They are not to be switched and moved. They have to go back where they were installed originally on the machine. So if you take these anvil mounts off, you must keep track of how many shims and what side they were on and to which anvil. That is absolutely critical. Otherwise, you will never be able to get a true good gap between your blade and anvils again. So once you get your gap as close as you can to a 5/1000th inch setting, so we just go across this edge, that's hitting right there, so that's less than 5/1000ths. That's passing. but I can still feel it. If you zoom in and look real close, you can see, I'll try and hold the shim so that you can see it kind of grab there. And I can feel it with my hand. I can feel the blade kind of grabbing the shim. That's how you check the tolerance. We want the machine to never operate above a gap of 25 thousandths of an inch. So that's right here. So compared to the optimum 5 thousandths, you can clearly see a very distinct thickness difference. So the thicker, as you approach the 25 thousandths gap between the cutting edge of the blade and the anvils, you will have a significant performance difference on the machine. The machine will be louder. It will sound like it's trying harder to make each cut. And over time, that can lead to damaging other components on the machine. So 25 thousandths is about the most you ever want the gap to ever get. If once you get to 25 thousandths, it's time to push the blade up and try and close the gap in. Or if the knife edge on the blade is too dull, just go ahead and call us and send them back, and we perform resharpening service. And just looking at, so these are mostly new blades have been inserted. And what we first noticed, now that we've got the whole top portion off, whoever did the blade setting on this machine did not get the blade straight. As we can see here, this end compared to that end is not straight. And if I take my feeler gauges and I go to a 22 thousandths thickness on my feeler gauge here, I can fit that all the way across the cutting edge relative to this anvil on both. Okay, and the problem with that is that's okay if we've got many tons worth of cutting on these blades, but these are brand new blades. There's only a few tons worth on here, so this gap is way too large. That gap, when a brand new blade is loaded, should be ideally between 5 and 10 thousandths of an inch from here all the way across. This blade relative to that anvil, this blade relative to this cutting edge on this anvil, and then as well the other blade should read very close to the same measurements relative to both anvils as well. You have to check all of those measurements. I take at least 6 measurements when I load brand new blades into a machine. So something isn't right here. I don't believe this blade was loaded in properly from the beginning, which obviously does not help the chip quality, and it also creates more stress on the machine because it's trying to cut with a larger gap. So we have to do a better job at getting that gap closer to the anvils.